rules of differentiation. So the next rule of differentiation is what we call the logarithmic. So logarithmic differentiation. So logarithmic differentiation is also another method of finding derivatives by first taking the natural logarithm of the function. But so before we demonstrate how to carry out logarithmic differentiation, let's see, start with an activity. Given y equals to f of x given by ln of x, find dy dx. I hope you can see my writings on the whiteboard.
Yes.
Okay, good. Yeah. So let's see how to deal with derivatives of logarithmic function. So when you are discussing different types of functions, you also encountered what we call logarithmic functions. So we have what we call natural logarithm. So which we just abbreviate by ln. And then the Napierian logarithm that you are familiar with in high school. So to compute the derivative of ln of x, so given y is ln of x, and when we write ln of x, by default, the base is always e. So the base here is always e. So sometimes it can be shown or sometimes it's not written there. But you have to remember that when you have an ln, then the base is this number e. So what we do, we convert this statement from logarithmic form into exponential form. Just to recall, in your high school work, if I give you log of, say, log of 100 to the base 10 is always 2, then this statement can be converted into index form as 100 is the same as 10 raised power 2. So this is in logarithm form, this is in logarithmic form, and then this in the exponential or the index form. So similarly, if we have y equals to ln of x, then in index form, we'll have x equals to e raised power y. So this statement and this statement mean the same, only that the first statement is in logarithmic form. This one is in the exponential form or in the index form. So then differentiate both sides with respect to x. So that is to say, we have d dx of e power y equals to d dx of x. So what will be the derivative of e power y with respect to x?
E power y.
So it is e power y, but remember what we were doing yesterday on implicit differentiation. Y is assumed to be a differentiable function of x, so you attach a dy dx on this answer. Yeah. Then d dx of x?
1.
1. Correct. So this implies that dy dx will be obtained by simply dividing both sides of this by e power y, e power y. So this will give us 1 over e power y. But we remember from here, e power y is the same as
X.
x. So this is the same as 1 over x. So in general, given y equals to ln of x, then dy dx is always given by 1 over x. Add this to your toolbox. So add this to your toolbox on how we deal with the logarithmic function ln. So the function ln of x, its derivative is 1 over x. So compute dy dx for the following. So the first one, y equals to ln of 2x plus 3. Then b, y equals to ln of x squared plus 4x plus 5. So the solution will be y for part A is given by ln of 2x plus 3. So how do we start? Following the yesterday's discussion. How do we begin? What will be the starting point? So solution, we let this bracket to be u. So let u to be 2x plus 3. Therefore, y will be? What will be y? If y is ln of 2x plus 3. And we are saying let 2x plus 3 to be u.
ln u.
ln of u. Correct. So this implies the u dx will be?
U dx will be ln. Huh?
2.
2. Just using power rule 2. And what will be dy du?
ln.
So remember y is ln of u. So what is dy du? Don't forget where we're coming from. We are saying that when you are given y equals to ln of x, then dy dx is given by 1 over x. So if I have y as ln of u, what is dy du?
1 over u.
1 over u.
1 over u, correct. So this will be 1 over u. So which means by chain rule, dy dx will be given by dy du times du dx. So which means I will have dy dx will be 1 over u multiplied by du dx, which is 2. So this is the same as 2 over u, which is the same as 2 over 2x plus 3. So that will be the derivative of that given function. So I want you to note this function and note the final answer. This function and this derivative as 2 over 2x plus 3. Then let's go to the second one. So we have ln of x squared plus 4x plus 5. So y equals to ln of x squared plus 4x plus 5. So as usual, we let u to be x squared plus 4x plus 5. So therefore, by fixing this to u, y will be ln of u. So what will be du dx?
2x plus 4.
2x plus 4, correct. And dy du?
1 over u.
1 over u, correct. So by chain rule, dy dx is the same as dy du times du dx. So which will be 1 over u times 2x plus 4, which will be given by 2x plus 4 divided by u, which is x squared plus 4x plus 5. So this will be our dy dx function, or dy dx solution. Then next one is y equals to ln of x cubed plus 1. Please try to work out the dy dx for this function. You're following the same process. Compute dy dx for this using same process.
Two over x squared plus 1.
What then? Dy dx
2x.
equals to?
Yes,
3x.
2x over x squared plus 1.
I think you have copied the wrong function. Any different answer?
3x squared over x cubed plus 1.
3x squared over x cubed plus 1, correct. Then D, y equals to ln of square root of sine x. So what would be the choice for you in this case? We'll let you to be. What the best choice for you? You would be?
Root sin x.
Root of sine x. So we get same as sine of x power a half. So therefore, y would be ln of u. So can you compute du dx?
Cos x. But
Cos
half.
x power?
A
Cos
half.
x power half. Which technique will you use to get the derivative of u? Which differentiation technique do you use to get du dx?
Rule. And special.
How do you get the derivative of u if u is sine of x power half? Which differentiation method?
Rule.
Power rule is only applicable for polynomial functions. So you are going to use chain rule still on this one here. So you fix this one, say to u, can use different notation. Let sine x to be u. And then we'll have now this small u will be the same as u power a half. Then repeat the same process of chain rule. So I'll have, when you fix this one to a variable u, then I'll have u equals to u power half. So their power will be applied. So I'll drop their half. Then I'll have sine of x. A half minus 1 is minus a half. Then when I differentiate this sine x, I get cos x. So this will be the solution. So remember, this has been obtained by chain rule. Then dy du will be dy du
1 over u.
1 over u. So by chain rule, dy dx is given by dy du times du dx. So which will be 1 over u times a half sine power negative a half, and x power negative a half, then times cos x. So which will be a half. Now when I say sine x power half, if I want the power to be positive, I'll have sine x power negative a half. If I want that to be positive a half, then will be how will we write that expression? This is what we'll have. So we'll have cosine x over 2. Then u is sine power a half. Cosine x power half. Then times this other sine x power half. So what is sine x power half times another sine x power half? Okay.
Sin squared power a quarter.
So which rule are you using? So this is just loss of indices. If I have a power half times a power half, what do I get? Where a sine x?
A power quarter.
How are you
A
getting
power.
Just a power half plus a half. Yeah. Good. So just a. Please revise your form 2 up. So this will be cosine x 2 sine x. So if you like, you can write this one as a half. Cos over sine is given by cos over sine is the same as
Tan.
cot. So that's reduces to a half cot x. Then lastly, before we make some generalization,
Excuse. What if you
yes?
leave your answer? What if you leave your answer at cos x over 2 sin x? Is there any problem?
No, there's no problem.
Okay.
Yeah, unless the question now boxes you in a corner that show that the derivative will be given by a half by cot x, then there's still no problem even if you stop here. So the other one is y equals to ln of cos x plus x squared plus e power x. So what will be the starting point? This case? How do we start? Don't complicate the obvious. The process is the same as what we have done in the previous problem. We start by
Let
Let
me-
cos x.
yeah, so we let u to be
cos x plus x squared plus e power
yeah
x.
cos x plus x squared plus e power x, correct. So by doing that one, then we'll have y equals to ln of u. So du dx in this case will be
negative sine x plus
negative
bx.
sine x
plus
plus
2x
2x
plus this power x.
e power x, correct. And dy du
1 over u.
1 over u. So by chain rule, dy dx is dy du times du dx. So dy du is 1 over u times du dx is negative sine x plus 2x plus e power x. So which will just be negative sine x plus 2x plus e power x divided by cos x plus x squared plus e power x. So that would be the answer. So if I give you y equals to ln of f of x, what will be dy dx? If you can relate what you have done in A, B, C, D, and E, what can you say about the structure of the function and its derivative whenever you are dealing with an ln function? Is there a common trend you can see from the final answer and the nature of the function? What's happening?
f prime of x over f of x.
Correct. Yeah, we can clearly see that the way the ln function is behaving is that when you have y equals to ln of some function, then the final answer is a fraction such that the denominator is the function itself, defined for ln, and then in the numerator is the derivative of that same function. So dy dx would be f prime of x divided by f of x. That can also be added to your toolbox, that in general, given y equals to ln of u, where u is a function of x, then dy dx is always given by u prime over u, which is the same as f prime of x over f of x. This will also be added to your toolbox. It can help you to reduce or to find derivative of functions involving logarithmic function. So activity number 2, given y is log of x to base a, where this a is positive and this a is not allowed to be 1, find dy dx. So it is very easy to work out the value of this derivative if you convert the log function into exponential function and then use the same concept on how to deal with the logarithmic function you have done in the previous activity. So what is the, if I have y is log of x to base a, when you convert this into index form, we'll have Can you convert this into index form? Don't disappoint your Form 2 maths teacher. Y is log x to base a. In index form, we'll have
A power y is equal to x.
yes, a power y is equals to x. Correct. So then now call this one. Then next, introduce ln on both sides of 1. That is, I'll have ln of a power y is equals to ln of x. Then from your Form 3 work, if you have log of a power n, how can we rewrite this log expression?
N log a.
N log a, correct. Similarly, if you are given ln of a power m, then this is the same as m ln of a. Now, all the rules on the normal, the parent logarithm that you learned from the high school are exactly the same way we interpret this natural logarithm function. So we also can drop this power and then ln of a. So this can be rewritten as drop this y ln of a equals to ln of x, just by using this property of log. So the next now, call this 2. Now differentiate both sides of 2 with respect to x, i.e. d dx of y ln of a equals to d dx of ln of x. Now, what is the derivative of y ln of a? Remember, ln of a is just a number, so you shouldn't confuse you with just the way I write maybe 10y or 20y or 30y, etc. ln of a is a number. So d dx of y ln of a will be maybe that's a hard question. If I ask you, if I have what is d dx of 10x, d dx of 10x, 10, correct. And then what is d dx of 50x?
50.
Okay. d dx of 50x?
50.
50. So it's the same thing. So this ln of a should not confuse the way you are interpreting 10 and 50, the same as ln of a. So then ddx of y ln of a will be which value? Still hard. So what will be the ddx of x ln of 5? ln of 5 is just a number. The way you are viewing 10x, the way you are viewing 50, 10 and 50, they are just constants. So ln of 5 is still just a number. So ddx of x ln of 5.
ln of 5.
ln of 5, correct. So then now, what would be now ddx of y ln of a?
ln of a.
ln of a, but then because this variable is y, you attach a dy dx. Remember the implicit differentiation process. So this will be ln of a, but then we attach dy dx because the variable here is y. So when you differentiate y with power rule, you get 1, but you attach dy dx since y is a differentiable function of x. Then ddx of ln of x from our previous discussion.
One over x.
1 over x, correct. 1 over x. So which means that when you make the y dx the subject, you have 1 over x times ln of a. And we can now make a generalization whenever we are dealing with log of x to base a function. So in general, given y equals to log of x to base a, then dy dx is given by 1 over x ln of a. Add this to your toolbox. Then activity number 3, given y is a power x, a is positive and also not 1, find dy dx. So here the process is, so we have the y equals to a power x. Please don't say that dy dx by power rule is you drop the x and then subtract 1 from x. This will lead you to hell. That can only be possible if now x is the base and then a is the power. Then that would be correct interpretation. But when x is the variable x is the power, then is not application of the power rule. So what you do is that you introduce ln on both sides. So ln of y equals to ln of a power x. Then the right hand side can be written as what will be other way of writing the right-hand side, ln of a power x. Using lots of logarithms.
X ln A.
X ln a, correct. X ln a. So then differentiate both sides with respect to x. So what would be the derivative of the left-hand side? Dx of ln of y. Okay.
1 over y.
1 over y.
Dy dx.
Dy dx. Don't forget that one whenever you are dealing with the variable y. Then the right-hand side derivative will be
ln
ln of a. So this means that dy dx alone, you multiply through by y, so you'll have y ln of a. But we know that y itself is a power x. So dy dx will be given by a power x ln of a. So we also make a generalization that given is a power x, then dy dx is given by a power x ln of a. So the reason as to why going through the process of deriving the derivatives of these functions is to make you not to cram any of these formulas, to actually to be able to find them on your own if you can't recall. Because there are many formulas which you may not actually be able to recall. So when you know how to derive or how to obtain them, then it becomes easier for you to know what you're supposed to do if you're given a problem. So let's provide some examples here. Find dy dx given a y equals to 3 power x. So if you remember the formula, then you simply say that this implies dy dx, our a is 3, so just be 3 power x ln of 3, if you remember the formula. But if you don't remember, you also don't have to cram. You can just say, when you have y equals to 3 power x, introduce ln on both sides and say ln of y equals to ln of 3 power x, which implies we'll have ln of y equals to x ln of 3. Then now use implicit differentiation to differentiate both sides. So we'll have d dx of ln of y equals to d dx of x ln of 3. Then you know that d dx of ln of y will be 1 over y dy dx, and d dx of x ln of 3 will be ln of 3. So with that, you make dy dx a subject, so dy dx will be given by y ln of 3, but you remember y alone is 3 power x. So this will be 3 power x ln of 3. So if you remember the formula, well and okay. If you don't remember, you still don't have to worry. Just go through the long process or the whole process of getting the derivative and you'll still arrive at the correct solution. Then B, y equals to 3 raised power minus x. So you can use chain rule here. So you let u to be minus x so that y will be 3 power u. So du dx will be if u is minus x, what is du dx? Du dx will be
-1.
-1, correct. So then, and what will be dy du? So it will be -1 and dy du will be 3 power u ln of 3. So therefore, this is -1, not negative x. So this is -1. So by chain rule, dy dx is the same as dy du times du dx, which will be 3 power u ln of 3 multiplied by -1, which will just be minus 3 power u ln of 3. But you don't leave your answer in terms of u, you replace its equivalent expression in terms of x. So the answer will be minus 3 raised power minus x ln of 3. Then C, y equals to 3 raised power sine x. So what will be the first step to compute this?
Chain will let you be sine x.
Yeah, let u to be
Sine x.
sine x, correct. So by doing that, y will be
3 power u.
3 power u, correct. So du dx
Cos x.
cos x and dy du
3u ln 3.
3u ln of 3, correct. So therefore, we'll have by chain rule dy dx is dy du times du dx, which will be 3 power u ln of 3 times cosine of x. So which this we can write as 3 raised power sine x ln of 3 times cosine of x. So this will be the final answer. Then I want you to try this. What is the derivative of the function y equals to 4 raised power 3x? And another one, y equals to 5 raised power x squared. So follow the same process in 2 minutes time and find dy dx for these two functions. Once you are done, you unmute and then say the answer. So in that process, we can now have a small break. So resume at 10:10.